Some nights the sky holds a kind of stillness that feels almost like a held breath, as if the whole world has paused just to let you rest inside it for a while. If this feels like a good place to settle tonight, you are welcome to stay just as you are with nothing left to hold on to. Now, let's drift. There is a strange and quiet truth that has followed you since before you can remember something so constant that the mind has stopped noticing it at all. It moves through your body right now, through the mattress beneath you, through the walls of this room, through the air, settling slowly around you. It seems that this invisible presence has shaped almost everything you have ever felt. Every fall, every rest, every breath that has ever left your chest. Tonight, we will let it carry us somewhere gentle. For most of history, people simply called it weight. They felt the ground holding their feet the way an apple finally lets go of its branch, the way water always finds its way down rather than up. It was so ordinary that almost no one thought to ask why. And then a little over 300 years ago, a quiet, watchful mind began to wonder, in the hush of an English garden, whether the same invisible pull that brought an apple to the earth might also be the very thing holding the moon in its slow, endless turn around our planet. Researchers have found that this single moment of wondering eventually grew into one of the oldest and most enduring ideas in science, the idea that every object with mass quietly reaches toward every other object with mass, no matter how far apart they happen to be. It is a strange thing to consider, really. Right now, as you lie here, you are gently pulling on the earth, just as it is gently pulling on you. The pull is impossibly small, smaller than anything you could ever feel, but it is there, woven into the space between your body and the bed, between the bed and the floor beneath it, between the floor and the deep, slow turning of the planet itself. Scientists suggest that this mutual pull, this soft and constant reaching, is one of the most patient forces in the entire universe. It does not rush. It does not demand attention. It simply waits and holds and continues. And for a long while this was enough to explain what people saw around them. An apple falls because the earth pulls it down. The moon stays in the sky because something keeps it from drifting away. But there was a deeper layer waiting beneath this idea, one that would not be uncovered for another 2 centuries, and it came from a mind that liked to imagine very strange and very quiet things. He imagined what it might feel like to fall in an elevator, with no walls to float weightless inside a falling box, and from that strange daydream came an idea so soft and so unexpected that it changed the way we understand the universe itself. It seems that gravity is not really a pull at all. It may be something closer to a shape, the gentle curve that mass presses into the very fabric of space and time, the way a sleeping body presses a soft curve into a mattress. Picture, if it helps, a stretch of dark, quiet fabric, smooth and weightless like the surface of still water at night. Now picture a single heavy object resting upon it, something large and slow like a planet. The fabric does not break. It only bends gently in a wide and gradual curve around that object. And if something small were to pass nearby, it would not be pulled in the way we once imagined. It would simply follow the curve, the way water follows the lowest point in a riverbed, the way a sleepy thought follows the curve of a half-finished dream. The brain tends to interpret this as a kind of falling, but what is really happening, scientists believe, is something quieter than falling. It is following a shape that was already there. This is part of why the moon never crashes into us and never drifts away into the dark either. It is endlessly following the curve that the Earth presses into space, caught in a long, slow fall that never quite reaches the ground. Astronomers have observed this same pattern across the whole of the night sky, planets curving gently around stars, moons curving gently around planets, each one tracing a soft, unhurried path, shaped by something it cannot see and does not resist. There is something quietly comforting in that if you let yourself feel it. Nothing up there is struggling. Nothing is being dragged. Everything is simply following the shape it was given, the way your own body right now is slowly settling into the shape of whatever is beneath you. It may be that this is part of why falling sensations feel so deeply familiar to us even in dreams. Long before any of us understood gravity as a curve in space, our bodies already understood gravity as a feeling. Psychologists often note that some of our earliest physical memories, even before language, are built around this single sensation, the soft drop of being lowered into a crib, the gentle sway of being carried, the quiet adjustment the body makes each time it is asked to rest somewhere new. Gravity in this sense is not only something written into equations, it is something written into the body itself long before any of us had words for what it was. It seems that gravity has always existed quietly inside two different worlds at once. There is the vast world filled with stars and galaxies and slow-turning planets where gravity curves entire stretches of space across unimaginable distances. And there is the small world, your world right now in this room, where gravity simply means the weight of a blanket, the soft give of a pillow, the way your shoulders are slowly allowed to stop holding themselves up. Both of these are the same force. Both of these are the same quiet, patient pull, reaching from one mass to another, never asking for anything in return except permission to hold what it touches just a little closer to the earth. There is still so much that remains gently unresolved about it even now. Scientists are still exploring the deepest edges of what gravity truly is, how it connects to the smallest particles in the universe, how it behaves in places so extreme that ordinary explanations begin to lose their shape. But none of that needs to trouble you tonight. What matters here in this slow and quiet hour is simply this. The same force that holds whole galaxies together is the same force resting gently against your back right now, asking nothing of you but to let it do what it has always done. And somewhere beneath that thought there is another one waiting softer still about the way falling does not always have to feel like falling at all. There is something the moon has been doing every single night of your life, something so slow and so quiet that almost no one ever stops to notice it. It is falling. It has been falling for over 4 billion years, and it has never once reached the ground. It seems strange to say it that way because the moon looks so steady up there, so fixed in its place, hanging above the rooftops and the rivers and the quiet edges of every sleeping town. But researchers have found that stillness is something of an illusion. The moon is not resting in the sky. It is caught in an endless gentle fall toward the earth, curving downward at every single moment and yet never arriving. It simply keeps missing the ground over and over in the softest possible way. To understand why, it helps to imagine something very ordinary. Picture a stone thrown across a quiet field. It leaves the hand curves through the air and eventually meets the earth. Now imagine throwing that same stone harder and harder again until it moves so fast that by the time it would have fallen, the ground has already curved away beneath it. It keeps falling and the world keeps curving out of reach, and the two simply continue together forever, almost touching. This scientists suggest is the quiet secret behind every orbit in the sky. Not a stillness, a fall that never quite finishes. The moon moves around the Earth at a little over 2,000 miles an hour, which sounds fast, almost urgent, and yet from here, lying in the dark, none of that speed is visible at all. It seems that distance has a way of turning motion into calm. What feels frantic up close can feel almost motionless from far away, the way a fast river looks smooth and silver when seen from a high hill. There is something quietly comforting in that thought if you let it settle for a moment. Even great speed from the right distance can look like peace. This same gentle falling happens everywhere above us, not only with the moon. Every planet circling the sun is doing the same thing, endlessly falling toward a star it will never reach, caught in a curve too vast and too patient to ever resolve into a collision. Evidence suggests that this has been happening since the solar system first began to settle into its shape billions of years ago, when scattered clouds of dust slowly gathered themselves into spinning, falling worlds. Earth itself has been falling around the sun for longer than there have been eyes to notice it, and it will likely continue falling long after we are gone in the same unhurried circle, the same quiet, unfinished collapse. There is something almost tender in imagining it this way. Picture the whole solar system not as a fixed diagram, the kind we saw pinned to classroom walls as children, with neat circles and careful arrows, but as something more alive than that, a slow and continuous falling, each world held in a long embrace. It will never escape and never complete. The mind tends to picture gravity as something that ends a final landing, a definite arrival. But up there it rarely does. It simply continues soft and circular like a held note that never quite resolves. It may be that this idea of falling without arriving feels familiar to you in another way too, somewhere outside of astronomy altogether. Psychologists often note that the human body carries its own private memory of falling, formed long before any of us understood orbits or curves in space. It begins in the earliest months of life when an infant lowered gently onto a soft surface sometimes extends its arms outward in a sudden reflexive motion. This response has existed in us since before we could form a single memory, a quiet echo of some ancient need to catch ourselves. It seems that falling even in its gentlest form has always asked something of the body, an old and automatic kind of attention. And yet there is another kind of falling that asks the opposite of us, the kind that happens at the edge of sleep. Neuroscientists have observed that many people experience a small sudden jerk in the body just as they are drifting off, often accompanied by the sensation of falling from somewhere high. This is sometimes called a hypnic jerk. And what we understand so far suggests it may happen because the brain, while drifting between waking and sleep, briefly misreads the body's relaxing muscles as the beginning of an actual fall and responds the way it always has, with a small startled catch. It is the same old reflex the moon seems to share in its own enormous silent way. A motion that begins like falling and ends without ever landing. There is a kind of grace in realizing that falling is not always something to resist. Up there in the vast dark above this room, the moon has never once tried to stop its fall. It does not resist the pull of the earth, and the earth does not resist the gentle weight of its turning. They simply continue together in a long and patient agreement neither of them ever has to think about. The mind quietly registers somewhere beneath conscious thought that this kind of yielding does not always mean loss. Sometimes it only means rhythm. If you were able to step far enough away from this planet, far enough to see the whole system turning quietly in the dark, you might notice something almost musical about it. The moon circling the Earth roughly once every 27 days. The Earth circling the sun once across an entire year. Even the sun itself slowly carried along the spiral arm of an enormous galaxy, completing one single circuit roughly every 225 million years. Each motion nested gently inside another, like the slow layered breathing of something far too large to ever fully picture, only to feel. It seems that gravity in this sense behaves less like a force pulling things downward and more like something holding a long and unhurried conversation across great distances, a conversation made entirely of curves instead of words. The moon answers the earth answers the sun. Nothing rushes to reply. Everything simply continues in its own time, in its own quiet circle. There is no need to hold on to any of these numbers, the days or the years or the millions of years stretching far beyond comprehension. What matters more in this slow hour is only the shape of the idea itself, the sense that falling does not have to be sudden, that it does not have to end in impact, that sometimes it simply continues soft and endless, the way your own breath continues now without you needing to direct it. Somewhere far above this room the moon is still falling, the way it has always fallen, the way it will keep falling long after tonight has quietly come to its end. And somewhere closer than that, much closer, there is another kind of fall happening too, a quieter one your own body seems to remember from somewhere even further back than memory itself. There is a small, quiet part of the body that has been listening to gravity since the very first weeks of life, long before any of us had words for up or down. It sits deep inside the inner ear, smaller than a grain of rice, and it has spent your entire existence quietly tracking the pull of the earth. This part is called the vestibular system, and researchers have found that it works by sensing tiny shifts in fluid and delicate crystals resting inside the inner ear, each one responding to gravity the way a small leaf responds to the slightest breath of wind. It seems that this system never fully turns off. Even now, lying still in the dark, some quiet part of it continues working gently, confirming again and again which way is down. It is strange to think that something so small has been with you for your entire life, working in complete silence, never once asking for attention. Studies indicate that this same system begins forming before birth, deep inside the womb, long before a baby ever opens its eyes or takes its first breath. By the time you were born, your body already understood gravity in a way your mind had not yet had the chance to learn. There is something quietly moving in that the idea that some forms of knowing arrive in us long before language does, carried, not in thought but in balance itself. This is part of why infants, when lowered gently, sometimes throw their arms outward in a small sudden motion, as though trying to catch something invisible. Psychologists often note that this reflex, sometimes called the Moro reflex, appears in nearly all newborns and tends to fade within the first few months of life. It may be one of the oldest physical memories the human body carries, older even than memory. A kind of ancient caution passed down through countless generations who once needed to catch themselves quickly from real sudden falls. The body remembers what the mind cannot. There is something tender in imagining this small reflex stretching backward through time, generation after generation, long before soft beds or warm rooms, back to a time when falling truly meant danger. And yet here you are now, lying somewhere safe and unhurried, and that same ancient caution has nothing left to do. The brain tends to register safety quickly when there is no real fall to prepare for, and slowly the old alertness softens into something closer to stillness. This vestibular system does more than track falling, though. Evidence suggests that it constantly compares what the eyes see with what the inner ear feels, blending the two into one steady, quiet sense of where the body is in space. This is part of why closing your eyes right now may feel like it deepens the stillness in the room. With one sense quieted, the body leans a little more fully into what the inner ear already knows, trusting balance instead of sight, trusting feeling instead of looking. It seems that this same system is part of why certain motions feel soothing rather than disorienting. The slow rock of a hammock, the gentle sway of a train at night, the rhythmic motion of being held and rocked as an infant. All of these create slow repeating signals that the vestibular system seems to interpret as safety rather than threat. Neuroscientists have observed that gentle rhythmic motion can quiet activity in certain alert centers of the brain, easing the body toward rest rather than vigilance. Perhaps this is part of why so many people sleep more easily in moving vehicles, in rocking chairs, in the soft sway of a hammock strung between two trees. The body in motion sometimes remembers how to let go. There is a quieter layer to this, something most people never think to consider. The same sense that tracks gravity also seems to soften gradually in the final minutes before true sleep arrives. As the body relaxes and stillness deepens, signals from the vestibular system become quieter, less urgent, less involved. It may be that this gentle hush is part of what allows certain unusual sensations to surface right at the edge of sleep. The soft, floating feeling some people notice just before drifting off completely, almost as though gravity itself has loosened its grip for a moment. What we understand so far suggests that this floating sensation, sometimes called hypnagogic drift, may come from a brief mismatch between what the inner body expects and what it is currently sensing, a kind of soft static between waking instructions and sleeping stillness. There is nothing alarming in this. It is simply the body easing its old careful watchfulness, allowing balance itself to rest alongside everything else. There is something almost beautiful in realizing that the same ancient system that once helped a falling infant catch itself is the very same system now helping you settle more deeply into where you're lying right now. It has spent a lifetime sensing gravity so closely that it barely needs to think about it anymore. It simply knows the way an old familiar song is known without ever needing to be learned again. And there is something else. This same small, quiet system seems to be involved in something the body has carried for far longer than anyone first expected, something that surfaces only in the deepest, gentlest moments of rest. There is a particular feeling that sometimes arrives just before sleep, a soft, sudden sense of sinking, as though the bed had quietly grown deeper beneath you. It happens so often in bedrooms everywhere that almost no one stops to ask what it actually is. Researchers have found that this sensation is closely tied to a natural process. The body performs every single night something called muscle atonia, a near total loss of muscle tension that begins as the body prepares for deep sleep. It seems that as wakeful muscle tone fades, the brain, still half alert in those final minutes, sometimes briefly loses track of where the body actually is. For a moment, gravity feels less certain, and the body responds the only way it knows how, with a soft sinking sensation as though settling into something deeper than the mattress itself. It is a strange kind of overlap when you think about it. The body and the mind do not always fall asleep at exactly the same moment. Studies indicate that certain regions of the brain begin slowing, first easing into stillness, while other regions remain quietly active just a little longer, monitoring, sensing, half listening. In that narrow window between the two, awareness sometimes drifts into unusual shapes. A weightless feeling, a sense of dropping gently through the dark, a soft, brief blurring of where the body ends and the bed begins. There is something almost touching in imagining the brain this way, not as a single switch turning off all at once, but as a slow, uneven settling, like a house where the lights go out one room at a time. The bedroom dims first, the hallway lingers a little longer, and somewhere in that quiet, unfinished darkness, a feeling like falling sometimes slips through, not because anything is wrong, but simply because the body is changing shape from wakefulness into rest. This same overlap may help explain why some people experience a faint floating sensation that lasts only seconds, while others sink heavily and quickly almost the moment their eyes close. Evidence suggests that the depth and speed of this transition can vary widely from person to person, shaped by tiredness, stress, posture, even the temperature of the room. The mind quietly registers all of these small conditions without ever announcing them, adjusting the descent into sleep the way a hand adjusts a blanket without needing to think about it. There is another layer to this gentle sinking feeling, one that reaches back further than sleep itself. Psychologists often note the human nervous system has long associated softness and lowering with safety, an old inherited pattern formed across thousands of generations, who slept curled close to the ground, low and hidden away from danger. To lower the body slowly to feel oneself sink into stillness may be one of the oldest physical signals of safety the body has ever known. Perhaps that is part of why a heavy blanket or the gentle weight of another body nearby can feel so calming. The mind tends to read weight not as restriction but as reassurance. It may be that this is also why deep pressure, the kind felt from a weighted blanket or a firm embrace, has been studied for its calming effects on the nervous system. What we understand so far suggests that steady, even pressure across the body can lower activity in certain alert centers of the brain, easing the nervous system away from vigilance and toward rest. There is something quietly poetic in that the idea that weight itself, the very thing gravity is made of, can become a kind of comfort, rather than a burden, simply by arriving gently and staying still. Sinking in this sense may be one of the gentlest words the body knows. It does not mean falling apart. It does not mean losing control. It seems to mean something closer to release, the slow, voluntary letting go of muscles that have spent all day quietly working, holding posture, holding tension, holding the shape of being awake. At night, gravity is finally allowed to finish what it has been asking for since morning. The shoulders soften, the jaw loosens, the whole body, piece by piece, lowers itself fully into the mattress as though remembering after a long day exactly how to rest. There is a particular kind of stillness that follows this letting go, a stillness that feels different from simply lying down. Neuroscientists have observed that as muscle tone fades further, breathing tends to slow and deepen, heart rate eases, and the whole body settles into a rhythm calmer than almost anything experienced while awake. In this state, the mattress no longer feels separate from the body. The two seem to blend together, weight meeting weight, gravity meeting rest, until it becomes difficult to say exactly where one ends and the other begins. It seems that this sinking feeling, this soft surrender into the bed, is not a malfunction of the body at all, but something closer to an old practiced skill, quietly performed every single night without applause or attention. Long before anyone studied gravity in equations or curves, the body had already learned how to receive it gracefully, how to let it hold rather than take. There is something else gravity seems to do once the body has settled this deeply, something subtler, something that touches not just muscles and weight, but the quiet drifting edges of the mind itself. There is a number very small and very old that quietly governs the distance between every two things that have ever existed. It is called the gravitational constant, and although it rarely enters ordinary conversation, it has been at work in every single moment of your life without pause, without exception. Researchers have found that this constant is almost impossibly tiny, so small that the pull between two ordinary objects, two people standing close together, two books resting side by side on a shelf, is far too faint to ever be felt. And yet it is there. It seems that gravity does not care how small or how unremarkable an object is. The moment something has mass, it begins reaching quietly and endlessly toward everything else that also has mass. This means that right now in this room you are gently pulling on the walls around you. You're pulling ever so slightly on the lamp across the room, on the door, on anything within reach of this invisible patient attraction. Studies indicate that even two people sitting near each other exert a measurable gravitational pull on one another, far too small to sense but real enough to calculate. There is something quietly moving in that thought, the idea that closeness itself, even in something as small as gravity, has always had a kind of pull built into it long before anyone gave it a name. This is one of the gentler truths Newton uncovered centuries ago, sitting with nothing more than careful thought and an old curiosity about falling apples and distant moons. He proposed that every object with mass attracts every other object with mass, and that this attraction grows stronger as objects come closer together and weaker as they drift apart. It seems such a quiet idea now, almost too simple to have changed the world, and yet it explained for the first time why the planets stayed in their paths, why the tides rose and fell, why nothing in the sky ever simply floated away. There is something tender in picturing this kind of pull at work across the universe. Two stars light years apart reaching for each other, with a force too weak to ever bring them together, yet too persistent to ever fully let go. Two planets circling a shared star, each subtly aware of the other's presence, bending their paths just slightly, because something somewhere insists on reaching back. Evidence suggests that even the smallest gravitational pulls accumulated across enormous distances and long stretches of time have shaped the structure of entire galaxies, slowly gathering scattered matter into spirals, clusters, and quiet drifting clouds of stars. It may be that this is part of why gravity feels different from the other forces that shape the universe. Unlike most forces which can push as easily as they pull, gravity only knows how to bring things closer. The mind quietly registers that there is something almost gentle in this, the idea that an entire universal force exists for the single unwavering purpose of pulling things nearer to one another, with nothing in its nature built for separation. This same quiet pull is why the Earth holds onto the Moon and why the Sun holds onto the Earth, but it is also why something far smaller is happening between you and everything close to you right now. The mattress beneath you is pulling on you faintly. You're pulling back. The air in the room, light as it feels, carries the smallest measurable mass and therefore carries the smallest measurable pull as well. Nothing in this room is truly separate from anything else. Everything is reaching, however faintly, toward everything around it. Psychologists often note that human beings seem to carry an emotional echo of this same principle, an old instinctive sense that closeness creates connection, that proximity itself can feel like a kind of bond. It may be only a metaphor, a borrowed image from physics rather than a literal explanation of feeling, but there is something soothing in noticing the parallel anyway. Just as mass quietly reaches for mass presence, often seems to quietly reach for presence, two people in a room settling without realizing it into a slow and natural gravity of their own. What we understand so far suggests that gravity becomes truly powerful only at enormous scales, when enough mass gathers in one place to create a pull strong enough to hold moon-shaped oceans or bend the path of light itself. A single human body on its own will never visibly move another simply through gravitational pull. But scientists are still exploring how this same fundamental attraction multiplied across stars and galaxies and unimaginable distances becomes the very architecture of the visible universe, the quiet scaffolding holding everything in its place. There is a certain comfort in imagining the universe this way, not as a collection of separate isolated objects drifting through emptiness, but as something deeply and continuously connected, each piece gently aware of every other piece, even across vast and silent distances. Nothing truly stands alone. Even in the coldest, emptiest reaches of space, something is still quietly reaching back. The body lying here now is part of that same old pattern, pulling and being pulled, connected by the faintest possible thread to everything nearby. And there is another kind of pull waiting just ahead, one that does not reach outward into space at all, but bends quietly inward, instead touching something far smaller and far closer than the stars. There is a kind of bending happening in the sky tonight that has nothing to do with wind or weather. It happens to light itself, the oldest traveller in the universe, the one thing we always assume moved in perfectly straight lines. Scientists suggest that light does not always travel straight at all. When it passes close to something massive enough, a star, a planet, an entire galaxy, its path quietly curves the way a path through soft ground curves slightly around a heavy stone. It seems that gravity does not only pull on matter, it reaches into something even lighter than matter, something with no mass at all, and gently bends its way as well. This was one of the strangest predictions ever made from a quiet daydream. The same mind that once imagined floating inside a falling box also imagined something far stranger. That space itself, the very emptiness light travels through, could be curved by anything heavy enough to leave a mark on it. If space curves, then light, having no choice but to follow the shape of space, must curve along with it. For years this remained only an idea, elegant but unproven, until astronomers found a way to test it during a total solar eclipse, when the sky darkens enough to reveal stars normally hidden behind the brightness of the sun. What they found watching carefully as starlight grazed the edge of the darkened sun was that the positions of distant stars appeared to have shifted ever so slightly, exactly where the bending of space predicted they should. Researchers have found this same effect again and again since then, watching how massive galaxies far away can bend and stretch the light of even more distant galaxies behind them, sometimes smearing that light into long soft arcs, sometimes splitting a single distant light source into several glowing copies of itself. This phenomenon, gravitational lensing, has become one of astronomy's gentlest illusions. A massive cluster of galaxies acts almost like an enormous invisible lens, bending and magnifying the light of whatever lies behind it. Studies indicate that some of the faintest, most distant galaxies ever observed were only made visible to us because of this quiet, bending light borrowed and bent by gravity until it became just bright enough to reach our eyes. There is something moving in that thought, the idea that without gravity gently curving the path of light, some of the oldest images of the universe might have remained forever invisible to us. It seems strange to imagine light, something so fast, so seemingly unstoppable, being shaped at all. And yet evidence suggests that gravity treats light the same way it treats everything else. Not by pushing or pulling it directly, but by curving the very space it moves through. Light is not forced off its path. It simply continues forward faithfully along whatever shape space happens to take. The bending is not resistance. It is obedience to a deeper geometry. There is a quieter layer to this one that most people never consider, something that touches not the stars themselves, but the silence between them. Astronomers have used this same gentle bending of light to detect objects that give off no light of their own at all, dark invisible masses whose presence can only be inferred by the way they subtly warp the light of everything behind them. In this way, gravity has become a kind of soft, indirect language, allowing scientists to sense the presence of things that can never be seen directly, only felt, only inferred through the world around thee. It may be that this idea carries a small quiet comfort beyond astronomy as well. Some presences, some influences leave no visible trace of their own, and yet the careful bending of everything nearby reveals that they were there all along. The mind quietly registers this kind of indirect knowing as something deeply familiar, the sense of feeling a presence before ever truly seeing it, the soft awareness of weight without ever needing proof. Closer to home, this same bending of light occurs on a smaller, gentler scale as well. The light from our own sun, what we understand so far, suggests bends slightly as it grazes the edge of massive nearby objects, an effect far too small to notice with the eye, yet large enough to measure with patient instruments. Even something as ordinary as sunlight reaching this room each morning has likely bent somewhere along its journey around something vast enough to leave the smallest mark on its path. There is something soothing in picturing the whole universe this way, full of soft curves rather than sharp lines, full of light quietly bending around things too heavy to ignore. The same way attention in a quiet room often bends gently toward whatever holds the most weight. Nothing in this picture is harsh. Nothing insists. Light simply follows the shape it is given, the way thoughts late at night often follow the gentle curve of whatever feeling is heaviest in the room. And there is something else. This bending seems to be quietly tangled up with something stranger, still touching not just where light travels, but how time itself seems to slow down wherever gravity grows just a little heavier. There is a quiet, almost unbelievable truth resting beneath this room right now, one that has nothing to do with clocks running fast or slow in the way we usually imagine. Time itself here near the surface of the Earth is moving at a slightly different pace than it does somewhere far above you in the thin, quiet dark of space. Researchers have found that gravity does not only bend light and curve the paths of falling moons, it also gently stretches time itself, slowing it down wherever gravity is strongest and letting it move just a touch faster wherever gravity is weaker. It seems strange to say that time can have a pacer tool, something we usually imagine as fixed and absolute, ticking the same way everywhere for everyone. And yet evidence suggests otherwise quietly and persistently in ways too small to feel yet large enough to measure. This idea first emerged from the same line of thinking that gave us curved space and bending light. The understanding that gravity is at its heart a curve in something called space-time, a single woven fabric made of the three directions we move through and the one direction we cannot, the steady forward flow of time. Wherever mass gathers, this fabric curves more deeply, and time bound up in that same fabric slows ever so slightly in response. The closer something sits to a massive object, the more gravity bends the space around it and the more gently time seems to drift forward. It may be hard to imagine this happening anywhere near something as ordinary as Earth, and yet studies indicate that it does in measurable, careful ways. Scientists have placed extraordinarily precise clocks at different elevations, some near sea level, others high on mountains or aboard aircraft, and found that the clocks positioned higher, farther from the Earth's strongest pull, tick forward just a few billionths of a second faster each day than the ones below. The difference is too small to ever notice in daily life, smaller than a single heartbeat stretched across centuries, and yet it is real, confirmed again and again by instruments built specifically to catch something so faint. There is something quietly moving in picturing this. Somewhere above this room, perhaps on a high mountain or somewhere aboard a satellite circling far overhead, time itself is in the gentlest possible way moving slightly ahead of the time passing here right now in this bed. Not because anything is wrong, not because anything is broken, but simply because gravity, wherever it is weaker, allows time a little more room to stretch forward freely. This same idea, oddly enough, is part of why a phone resting in your hand right now is able to tell you exactly where you are in the world. Evidence suggests that satellites used for navigation must constantly correct for this gentle difference in time, since they orbit far enough from Earth that their clocks naturally drift slightly ahead of ours. Without these careful corrections, the small mismatch in time would over only a single day throw positioning calculations off by miles. It seems strange that something as quiet and invisible as gravity's effect on him has in such a practical way helped guide so many people safely to where they were going. The mind quietly registers this kind of idea differently than most facts, perhaps because it touches something deeply personal. Time has always felt like the one thing entirely outside of our control moving forward steadily, regardless of what we do or where we are. And yet here is gravity quietly reminding us that even time bends, even time listens, even time moves just slightly differently, depending on where you happen to be standing or lying or drifting towards sleep. There is a soft kind of comfort in this if you let it settle. Right now your body rests closer to the Earth's pull than almost anything else nearby, closer than the ceiling above you, closer than the rooftops outside, closer than the clouds drifting somewhere overhead in the dark. This means that time for you in this exact moment is moving at its slowest possible pace. Within this room, the gentlest, most unhurried version of time available to you tonight. There is nowhere in this space where time passes more softly than exactly where you are lying right now. Psychologists often note that humans already experience time unevenly in their own minds, certain moments stretching long and slow, others slipping past almost unnoticed, shaped, not by gravity but by attention, emotion, and memory. It may be only a loose echo, a poetic parallel rather than a literal connection, but there is something tender in noticing how often our inner sense of time already behaves the way gravity describes it physically, slowing wherever something feels heavy enough to hold our attention, speeding quietly past wherever nothing much asks us to stay. What we understand so far suggests that these differences in time, though far too small to ever be felt directly, ripple outward in much larger ways across the universe, near enormous stars, near collapsing stellar remnants, near places where gravity grows far stronger than anything found on Earth. In those distant extreme places, time can slow dramatically, stretching seconds into something almost unrecognizable from the steady, gentle pace we experience here. None of that needs to trouble you tonight. What matters in this slow and quiet hour is simply the soft realization that time, like light, like falling, like weight itself, is not as fixed as it once seemed. It bends gently around whatever holds enough gravity to ask it to slow down, the way attention bends gently around whatever feels heaviest in a quiet room, the way your own breathing has likely already slowed without you needing to notice it happening at all. And somewhere beyond this slow bending of time there is another rhythm, waiting, one far older than clocks or satellites, one written instead into the rise and fall of entire oceans. Somewhere far from this room along a quiet coastline, the ocean is breathing right now, slowly the way it has breathed every single day for billions of years. It rises, it pauses, it withdraws, and the whole rhythm is set very gently by something hanging far above the water, something most people rarely think to thank for it. Scientists suggest that this rhythm, the tide, is created by the moon's gravity reaching down across 238,000 miles of empty space and pulling very faintly on the water covering our planet. It seems strange that something so far away could move something so vast and so heavy, and yet the ocean answers that distant pull twice a day almost everywhere on Earth in a slow and steady rise and fall that has continued since long before there were eyes to watch it happen. The moon's pull is strongest on the side of the Earth, facing it most directly, drawing the ocean very slightly upward into a gentle bulge. Researchers have found that something similar, almost like a mirrored answer, happens on the opposite side of the planet too, where the pull is weakest and the ocean bulges outward there as well, simply because the Earth itself is being pulled toward the moon a little more than the water on its far side. Two slow risings on opposite sides of the world, both caused by the same patient pull, both following the same curve. There is something quietly graceful in that a kind of balance neither side of the ocean has to think about, only follow. As the Earth slowly turns beneath these two bulges of water, most coastlines pass through both of them roughly once a day, which is why so many shores experience two high tides and two low tides within about 24 hours. Studies indicate that the exact timing shifts slightly each day, drifting later by roughly 50 minutes. Because the moon itself is also slowly moving along its own orbit, never staying in exactly the same place for very long. The tides in this way are never quite identical from one day to the next, always echoing the same rhythm yet never repeating it perfectly, the way breathing itself is never exactly the same breath twice. The sun joins in this rhythm too, though its pull on the oceans is gentler than the moon's, despite the sun's far greater size, simply because it sits so much farther away. Evidence suggests that when the sun and moon align closely during new and full moons, their combined pull creates especially high tides called spring tides, while at other points in the lunar cycle, their pulls partially cancel each other, creating gentler, smaller tides known as neap tides. It seems fitting somehow that even the ocean's rhythm has its own quiet seasons, stronger and softer, closer and farther apart in a long, slow cycle stretching across weeks rather than hours. There is something deeply soothing in picturing this entire system continuing tonight exactly as it always has, completely independent of anything happening in this room. Somewhere right now, water is rising gently against rocks worn smooth by countless years of this same motion. Somewhere else, water is slowly withdrawing, leaving behind wet sand that mirrors the sky above it for a few quiet minutes before drying. None of it needs your attention to continue. It simply happens the way your own breathing continues, unattended, steady, automatic. Psychologists often note that humans have long been drawn to the sound of moving water, particularly slow rhythmic waves, as something deeply calming to the nervous system. It may be that part of this comfort comes from familiarity, the way ocean sounds resemble the slow, steady rhythm the body has known since before birth, swaying gently inside the womb, surrounded by fluid, rocked by a heartbeat. The mind quietly registers these rhythms as something safe, something old, something the body seems to recognize even without ever consciously remembering where it first heard them. What we understand so far suggests that tides do more than shape coastlines. They quietly stir nutrients upward from the ocean floor, support entire ecosystems that depend on these rhythmic shifts between wet and dry, and even gently slow the Earth's own rotation by the smallest possible fraction of a second with every single cycle. Over hundreds of millions of years, this slow gravitational friction has gradually lengthened our days almost imperceptibly, one quiet tide at a time. It seems like such a small thing, the rise and fall of water along a distant shore, and yet scientists are still exploring just how deeply this rhythm reaches into the rest of the planet's systems, shaping ocean currents, influencing weather patterns, even subtly affecting how some marine creatures time, their feeding, their migration, even the phases of their own reproduction, all guided by a pull they cannot see, only feel. There is something quietly moving in imagining the moon distant and silent, asking nothing, expecting nothing, and yet still managing to coax an entire ocean into motion twice a day, every day, for longer than human memory can reach. It never demands the tide to rise. It simply curves space slightly and the ocean faithfully answers. Perhaps there is something in you tonight that moves the same way, rising and settling gently in response to something far away, something pulling so softly you barely notice the shift until it has already happened. And there is another rhythm waiting now, larger still, found not in oceans, but in the slow, patient turning of galaxies, holding each other close across the dark. Far above this room, farther than the moon, farther than the sun, there are entire galaxies moving slowly around one another, locked together in a dance so vast that a single turn can take hundreds of millions of years to complete. None of it can be felt, none of it can be heard, and yet it has been happening patiently since long before the Earth itself existed. Researchers have found that galaxies, those enormous gatherings of hundreds of billions of stars, rarely drift through space entirely alone. Many exist in pairs, in small clusters, or in vast, sprawling groups, held together across unimaginable distances by gravity, the same quiet force pulling on this mattress right now, simply acting on a scale almost too large to picture. It seems strange that a force this faint when felt between two ordinary objects becomes the very thing capable of holding billions of stars together as they slowly circle one another in the dark. Our own galaxy, the Milky Way, is no exception. Studies indicate that it's bound in a long, slow gravitational relationship with a much smaller galaxy, and that the two have been gently shaping each other for a very long time, exchanging trails of stars and clouds of gas as their paths drift closer with each passing era. This is part of how galaxies often grow, scientists suggest not in isolation, but through slow, repeated encounters with their neighbours, each meeting reshaping both galaxies just a little the way two slow currents merging in a wide river change the shape of each other's flow. There is something both humbling and oddly comforting in realizing that even galaxies do not exist entirely alone, that even something as vast as the Milky Way has spent billions of years quietly entangled with at least one close companion pulled gently toward it, pulling gently back, neither one able to fully separate from the other's influence. But there is a deeper mystery folded into this slow cosmic dance, one that scientists are still exploring closely. When researchers calculate how much visible matter, stars, gas and dust actually exists within most galaxies, the gravity produced by that matter alone is not strong enough to explain how quickly those galaxies are spinning, or how tightly distant galaxy clusters hold themselves together. Evidence suggests that something else, something invisible, something that emits no light at all, must be contributing significant additional gravity throughout the universe. Scientists have come to call this unseen presence dark matter, though the name itself admits how little is truly understood about what it actually is. It seems that the universe may be filled with far more gravitational influence than we can ever directly observe, vast amounts of unseen mass, quietly shaping the motion of galaxies, bending light in places that have no visible cause, holding entire galactic clusters together with a strength their visible matter alone could never provide. What we understand so far suggests that this invisible material may make up a significant majority of all the gravitational mass in the universe, far outweighing everything we can actually see with telescopes, stars, planets, glowing clouds of gas, all of it together. Still only a small fraction of what gravity reveals must be out there. There is something quietly moving in imagining this. The idea that presence does not always require visibility, that something can shape an entire galaxy, hold it together, guide its slow and graceful turning without ever once being seen directly. The mind quietly registers this kind of influence in familiar ways too, an old memory, an absent person, a feeling whose source is hard to name, each capable of shaping something deeply long after its visible form has gone. Psychologists often note that humans often sense connection and influence long before they can clearly explain it much, the way astronomers first noticed the unusual motion of galaxies before they could identify what was truly causing it. It may be that this is part of why dark matter feels even scientifically a little poetic, a vast and patient presence, unseen yet undeniable, holding the visible universe together from somewhere just out of sight. The mind, it seems, that has been keeping something still and patient all along, the same way the universe seems to be quietly held by far more than what meets the eye. These galaxies, bound to their unseen companions, continue turning tonight, exactly as they have for billions of years, unaware of clocks, unaware of human attention, simply following the slow curve. Gravity has given them visible and invisible together, weaving the same patient dance. There is nothing urgent in their motion, nothing rushed, only a long, soft turning that asks nothing of anyone watching except perhaps the quiet comfort of knowing something this vast can still move so gently. And closer than any galaxy, closer even than starlight, there is a smaller, quieter kind of gravity still waiting, one that lives not in space at all, but somewhere nearer to the chest in the soft weight carried by feeling itself. There is a kind of weight that has nothing to do with mass at all, a heaviness that can settle into the chest, the shoulders, even the eyes, without ever showing up on any scale. People have described it this way for as long as language has existed. A heavy heart, a weight lifted, a burden carried. It seems that the body borrows the language of gravity even when speaking about something far less physical. Neuroscientists have observed that this is not merely poetic exaggeration. The brain appears to process certain emotional states using some of the same regions and systems involved in sensing physical weight and bodily position. It may be that this overlap exists because emotional experience and physical sensation have always been deeply intertwined within the nervous system, sharing pathways, sharing language long before any of us had words like heavy or light to describe how feeling actually felt. This connection is partly explained by something called interoception, the body's quiet ongoing sense of its own internal state. Researchers have found that interoception allows the brain to continuously monitor heartbeat, breath, muscle tension, and posture, blending all of these signals into a single ongoing feeling of how the body is doing in this exact moment. Sadness evidence suggests often brings with it a real physical heaviness, a subtle slowing of movement, a slight downward pull in posture, shoulders curving forward as though something invisible were gently pressing down on them. There is something quietly moving in realizing that grief and gravity may share more than just a metaphor. Studies indicate that people experiencing emotional heaviness often report a literal sensation of increased weight, even though nothing in their body has actually changed. The mind quietly registers difficult feelings using the very same vocabulary the body uses to sense the Earth's pull. Perhaps because both experiences, gravity and grief, share the same essential quality of being, something pressed upon you, something you must learn to carry rather than resist. And yet the opposite happens too. Psychologists often note that joy, relief, and lightness of mood are frequently described using the exact opposite physical language, floating, soaring, weightless, as though some quiet inner gravity had momentarily loosened its grip. It seems that the nervous system has long understood happiness in part as a kind of release from weight and easing of the same heaviness. Sadness seems to deepen. This shared language between emotion and gravity may explain something else as well. Why physical comfort so often eases emotional discomfort, even when the two seem on the surface entirely unrelated. What we understand so far suggests that gentle, consistent pressure, the kind felt from a firm hug, a heavy blanket, or simply lying still beneath the quiet weight of one's own relaxed body, can measurably calm activity in certain stress-related regions of the brain. The body in this way seems to interpret weight not only as gravity's old and familiar pull, but sometimes as something closer to reassurance, evidence that something solid still surrounds it. There is a tenderness in imagining the chest as a small private place where gravity and feeling quietly overlap. Long before any equation described how mass bends space, people had already learned, through nothing more than lived experience, that emotional states have weight, that comfort often means slowing down enough to feel held, rather than untethered. Scientists are still exploring exactly how deeply intertwined these systems truly are, how much of emotional language is metaphor, and how much is something closer to a literal, shared neural experience. But even without a complete answer, the pattern itself feels strangely familiar, almost intuitive, the way certain truths feel obvious to the body long before science finds a way to explain them clearly. It may be that this is part of why simply lying still in a quiet room surrounded by nothing demanding immediate attention often eases emotional heaviness all on its own. The body no longer needing to hold itself upright, no longer needing to perform wakeful posture, allows gravity to do something it has always done well, settle everything gently downward, including perhaps whatever has felt heavy in the mind. There is a quiet kind of trust in letting the body rest this completely, trusting that gravity, the same patient force shaping galaxies and bending starlight, is also capable of something far smaller and far softer, easing a tired mind into something closer to stillness. The same force holding the moon in its endless gentle fall is in its own way holding you here too, asking nothing more than permission to let everything settle exactly where it already wants to be. And there is one more truth still resting quietly ahead. A final gentle reminder that everything this force touches, from galaxies to oceans to the weight inside a single chest, has always belonged to the same soft, continuous story. There are 4 fundamental forces that shape everything in the universe. And of all of them, gravity is strangely the weakest. It seems almost impossible to believe, considering everything gravity has done across the long quiet night, holding moons in orbit, bending starlight, shaping galaxies, pulling oceans into rhythm. And yet scientists suggest if you compared gravity directly to the other forces at work inside a single atom, it would be so faint by comparison that it barely seems to belong in the same conversation at all. The force holding atomic particles together inside the nucleus is almost unimaginably stronger than gravity, as is the force responsible for electricity and magnetism. The quiet push and pull behind everything from lightning to the static cling of a wool blanket. Researchers have found that if you could isolate gravity's pull between just 2 small particles and compare it to the electric pull between those same particles, gravity would be weaker by a number so large it becomes difficult to even picture a difference, stretching across dozens of zeros. It seems strange then that something this faint could be responsible for holding entire planets in orbit, for shaping galaxies, for keeping you resting gently against this mattress right now. But evidence suggests that gravity's quiet strength lies not in intensity, but in patience. Unlike the other forces, which tend to cancel each other out at larger scales, positive and negative charges, balancing opposite forces, neutralizing gravity, only knows how to add. Every particle of mass, no matter how small, contributes a little more pull, and as enough mass gathers together, planet by planet, star by star, that tiny persistent pull becomes powerful enough to shape entire galaxies. There is something quietly moving in this idea, the thought that the weakest force in the universe is also the only one patient enough to act across nearly infinite distances, indifferent to time, indifferent to scale, simply continuing gently for as long as mass exists to feel it. Studies indicate that gravity's effects, however faint at small scales, only grow more significant. The larger and more massive an object becomes, until eventually gravity alone becomes strong enough to crush stars, bend late, and stretch the very fabric of time itself. It may be that there is something gently encouraging in this pattern too, though it asks nothing of you directly. Small, quiet, persistent things, given enough time and enough accumulation, can become powerful far beyond what their individual strength would ever suggest. The mind quietly registers this kind of pattern in other places as well. Small habits, small kindnesses, small moments of rest. Each one faint on its own, yet capable over time of shaping something far larger than any single instance could ever hint at. Scientists are still exploring why gravity behaves so differently from the other 3 fundamental forces, why it remains so resistant to being fully unified with them inside one single elegant theory. Some have proposed that gravity might somehow leak into other dimensions invisible to us, diluting its strength compared to forces confined entirely within our own. Others continue searching for an underlying particle, sometimes called a graviton, that might carry gravity's influence the way photons carry light, though such a particle has never yet been directly observed. What we understand so far suggests that gravity remains, even now, one of the most familiar and yet least fully understood forces in all of physics. There is something comforting rather than unsettling in this lingering mystery. Despite everything still unknown, gravity has continued working exactly as it always has, holding this mattress steady beneath you, holding the moon in its endless fall, holding entire galaxies in their long, unhurried turning. It has never needed to be fully understood in order to be reliable. It has simply continued quietly, patiently since the very beginning of everything. Psychologists often note that humans tend to find comfort in patterns that remain steady regardless of whether they are fully understood. Heartbeat, tides, seasons, breath. Gravity belongs to this same quiet category, something trusted completely long before it was ever explained, and trusted just as completely now, even with so much of its deeper nature still unresolved. It seems fitting somehow that the weakest force in the universe has become the one holding everything else gently in place. Galaxies, oceans, falling moons, tired bodies sinking slowly into rest. Strength in this sense may never have been about force at all. It may simply have been about patience, about quietly continuing pulling softly, again and again, for long enough that the whole universe eventually arranged itself around that gentle, persistent presence. And now, after everything this slow curving force has touched tonight, stars, oceans, falling moons, tired chests, there is only one direction left for this story to settle, the same quiet direction gravity has always pointed toward, gently, patiently down. There is one more thing. Gravity does something so ordinary that almost no one ever thinks to notice it, and yet it has been happening to you this entire time, quietly without pause, since the very first moment you lay down tonight. It holds you here, not by force, not by pressure, not by anything that feels like effort at all. It simply curves the space around your body just enough that staying still becomes the easiest thing in the world. Researchers have found that this is in many ways the simplest expression of everything gravity has ever done. The same gentle pull that bends starlight, that slows time near massive stars, that keeps oceans rising and falling in their old familiar rhythm. All of it arriving here in this quiet room as nothing more dramatic than the soft, steady weight of a body resting against a mattress. It seems fitting that something capable of shaping galaxies should also be capable of something this small, this tender, this close. Gravity does not distinguish between the enormous and the intimate. It moves through both with the same unhurried patience, holding a spinning galaxy together with the same quiet certainty it uses to hold a blanket gently against your shoulders. Evidence suggests that the body, when finally allowed to stop resisting gravity, when muscles soften and posture dissolves into stillness, settles into one of the most efficient and restful states it can occupy. There is nothing left to hold up, nothing left to balance, only the slow, complete surrender of weight to whatever lies beneath it. This is perhaps the last quiet lesson gravity offers tonight, though it asks nothing of you in return. Falling does not always mean losing something. Sometimes it simply means arriving exactly where you were always meant to rest. The moon is still falling somewhere above this room. The tides are still answering somewhere far from here. Galaxies are still turning slowly, patiently, the way they always have. And here, in this much smaller orbit, your own breathing has likely slowed without you noticing, settling into something quieter, something heavier, in the gentlest possible way. There is nothing more to explain, nothing more to follow, only the soft, familiar pull that has been here the entire time, asking nothing, taking nothing, simply holding. The room around you may already feel dimmer than before. Thoughts may already feel farther away. Somewhere beyond the window, the sky continues holding its quiet shape. Somewhere closer, the body continues settling lower, softer, slower. There is a kind of stillness now that does not need a name, a weight that feels less like gravity and more like rest. The dark stretches gently around the edges of the room. Everything nearby has already gone quiet. Even the thought of falling has softened into something else, something without edges, something without weight at all, just this, just here, just the slow fading hush of a body finally letting go.